So today we will be learning about Python. Python is a programming language. What do we mean by programming language? So programming language is a language that helps us to interact with the computer. Computer only understands zeros and ones. So in order to interact with the computer, we need to interact it with zeros and ones only. So for that we have made different programming languages. So there are different programming languages out there. First programming language, so we have different types of programming language. Different types of programming language. First one is machine language. First one is machine language. So and second one is assembly language. Second one is assembly language. Third one is high level language. High level language. So these are the different types of programming language. Now, what is machine language? Machine language uses zeros and ones only. So in order to give instruction to the computer, we write our whole program in zeros and ones only. This is called a machine language. What is an assembly language? Assembly language uses zeros and ones also. Also they uses some symbols of a keyboard. That is an assembly language. Now what is high level language? High level language is simple English language. This is simple English language. This is simple English language. Okay. So high level language is a simple English language. But I said earlier that computer only understands zeros and ones only. So what happens is that when we write a program in simple English language, internally it will be converted into zeros and ones only. But right now we will write it in English language and internally it will convert it into zeros and ones only and execute our program. So that is what happens with high level language. Now there are different types of high level language. There are different types of high level language. In short, we can write it as HLL. HLL. There are different types of high level language based on program writing, how we write a program. So there are different types of high level language based on how we write a program, how we structure a program. There are different types of high level language. First one is procedural language. Procedural language. Second one is functional language. Second one is functional language. Third one is object oriented language. Third one is object oriented language. Right? So there are different types of high level language based on how we write a program, how we structure a program. First one is procedural language, second one is functional language, and third one is object oriented language. What do we mean by procedural language? Procedural language follows a step by step approach to write a program, to compose a program. So we follow a set of instructions to write a program. For example, we have to multiply two numbers. What will we do? We will first input our first number, then we will input our second number, then we will multiply both of them, then we will give the output. We can't just input the first number and give the output that this is the multiplication. No, we cannot do that. So that is procedural language. It follows a step by step approach. It follows a step by step procedure to compose a program, to execute a program, to write a program. That is procedural language. Another one is functional language. What do we mean by functional language? Functional language, so procedural language is just follows set of instructions, step by step approach of solving a problem. Now let's understand what do we mean by functional language. So there are some terms that is used in functional language. So functional language writes a program in pure function. In pure function. Okay. Also, it says that treat my functions as first class function. First class functions. First class functions. Okay. So it is said that write mostly write the program in pure functions. In functional language, they say write most program in pure functions and give it as a and treat it as a first class functions. Now what do we mean by pure functions and what do we mean by first class functions? Let's understand that. Before that, where we will be building, we will be doing our practical. So go to your Google Chrome or any browser you will be using and just type AWS Management Console. You will be redirected to some page. Sign up there. And when you come to home page, so this is the home page of AWS Management Console. Now there are different regions here. Okay. And they have different services. What do we mean by AWS? Amazon Web Services. This provide us a service. Means it provides service to us. And this service of can be of any type. This can be of it will give us some Ubuntu machine in rent and we can use it and we can return it. Okay. So you have to go here and go to compute. Go to services and go to compute. And then come to EC2. EC2 is Elastic Cloud Compute. Elastic Compute Cloud. It helps us to create virtual servers. So, using this, we will be having Ubuntu. We will be using Ubuntu using this service, using EC2. Go there, click on it. No instances are running. If no instances are running, then good. No billing will happen. If some instances will be running, it may reflect in your billing. So whenever you close your account, your practical, just stop your instances. Now go here, instances, and it is free to sign up and use its services as long as you are using free tier services. Now go to instances and go to launch instances if there's no instances already there. Now in launch instances, you have to name your instance. Let's say I want to name this Linux machine. Okay. Now you can select which operating system you want to use. Whether you want to use Mac OS or Ubuntu or Windows or Red Hat. There are n numbers of services. But some may be not on free tier. So Ubuntu is a free tier service. We will go with Ubuntu. Okay. So this is a free tier eligible written here. We will go with Ubuntu. Okay. So this is free tier T2 micro. Instance type is T2 micro. Now we have to create key pair login. If you have already created earlier key pair login, you can use that. I have created, I can use it. But if you are new to this dashboard, new to the service, you can say create new pair, new key pair. Now enter your key pair name. Key pair name could be anything. And in here, you want to create private key file format, .pam file or .ppk file. .ppk file is used to access our service, this Ubuntu service using Windows. But I want to use it from PAM only, means .pam file. This helps us to access Ubuntu service from our browser only. We want to access it from here. We can just type our name and we can just create key pair. It will be created when you click on it. I have already created earlier. I will go with that. Okay. Now just leave it as it is. and go to launch instances. Now it will launch your instance. Successfully initiated launch of instance. Okay, you can go to instances. Now it is saying instance status pending. You can refresh it. It may take some time. Give it some time to load. Your instance is loading, so it will take some time to run. Now it is running. Our instance state is running. Fine. Now we can select this instance and we go to actions and we can connect it. Now in connect, this is our username and we can directly connect on it. Fine. This is our public IP, this is our private IP. Now here we have this. This is called terminal. This is the terminal of Ubuntu. Ubuntu is a Linux distribution. And we can use this operating system to create a program. Now we can say we don't want this all on our terminal. We can say just clear. Clear is a command and it will clear out our terminal. It has cleared out our terminal. Okay. Now here if we do ls, ls is for list. List any file or folder or anything we have. So it will list. We have nothing on our home directory. This is our home directory. This tilde sign is a home directory. We have nothing in our home directory. We can create one folder in our home directory. We can say mkdir make directory. Mkdir stands for make directory. Directory is nothing, just a folder. For example, you create folder on your Windows. In Linux you create directory. So you can say mkdir make directory and we can name our directory anything we want and we can say enter. Now if we do ls, ls is used to list all the files and folders and anything that is inside our directory that we are inside in. We are inside in our home directory, so it will list all the folder and files or anything that is inside our home directory. Now we have Bharat. This is our folder. This is our directory. We can go inside our directory. In Windows, by double clicking on one folder, you can go inside that folder. In this, you can go inside it by using cd command. Cd change directory. Cd stands for change directory. You can go to Bharat. You can go to Bharat. Now I am inside my Bharat directory. See, earlier it was home directory. Now I am inside my Bharat directory. Now in Bharat directory, we will be seeing whether it has Python or not, installed Python or not. We can say using Python 3 version -- version and we can enter. Now it has shown us that it contains Python 3.10.6. So it contains Python and its version this 3.10.6. Fine. So we can use Python 3 here. Okay. So we will be using Python 3 to create our program. Now to create Python file, we have to use .py extension. So in different files has different extensions. For example, .jpg is used for saving images files. .docs doc is used to save doc file. In the same way, Python file has an extension of .py. So we can create a Python file. Here we have nothing. ls, nothing we have inside our Bharat directory. So we can say touch command is used to create a file. Touch, we want to say concept. Concept is my file name. .py is my extension. Enter. It has created a file concept.py. Now if I do ls, it will be created. Concept.py has been created. And now we can see that concept.py is here. Now we can use different text editor to edit our file. We have first text editor we can use is nano command. So nano is used to edit our text editor. Nano command is used to edit our text editor. We can say nano concept dot py, nano file name, enter. This is our text editor. Here we can edit our file, and we will be editing here only till we have to understand some complex problems. We will be coding here only, right? So we are inside a nano file. What we were understanding? We were understanding what do we mean by in function language, what do we mean by pure function, and what do we mean by first class functions. It asserts that we should use pure functions in functional language, and we should use first class functions. We can use our functions as first class functions. We can treat our functions as a first class functions. What do we mean by pure functions? Let's understand that. Now, what do we mean by pure function? Okay, so here we can say that def is a keyword used to create a function in Python. Def is a keyword. It has predefined function already attached to it. That is called a keyword which has predefined function attached to it. Def is a keyword which is used to create our function. We can say def function name, we can name it anything. Let's say add, and we have to add parenthesis here. After add, then we have to put colon, enter. Now we have to give some indentation so that our compiler should know, our interpreter should know that it is inside this function. We should give some indentation to it, and from here we will be writing our function, whatever function we want to write. Let's say I want to add two numbers, and I want to add two numbers. Okay, I want, before that, let's say inside add I want x. Okay, before that, before defining our function, we have some global variable. What do we mean by global variable? What is x? I will be telling you right now after some time, and we will be understanding it in functions when we will do functions. Okay, so here I have to put some global variable. Let's say y equals to 20. Okay, I have defined y equals to 20, and I have defined add x. Okay, before that, let me do this like that I have to define here only x comma y. We have two parameters here on our function. What do we mean by parameters? Parameters is nothing but it is inside our function definition. It is passed inside a function definition. Inside that parenthesis of our function definition, we have passed two elements, that is nothing but parameters. Inside this indentation, we will add some indentation, and we will say do x plus y. This is a simple function. We don't need to add semicolon here. And here we will be, okay, we will be doing x plus y. We will be returning x plus y. Return x plus y. Okay, or just save it somewhere and return that. Let's say do that. Okay, we can say x plus y, and inside it we have okay, we have put it inside z equals to x plus y, and we will return 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 z. Fine. Enter. Enter. We will call our function from here. We will say add. This is function calling. Okay. And we will save it somewhere. We will, let's say, I will save it, this add function calling in m equals to add. We will call our function. We will say 10 comma 20. Now it should give me 30. Why? Because 10 has been passed to x and 20 has been passed to y. This is argument we are giving. This is the actual value. We want to have it here inside our function, and we are calling our function. Function, what do we mean by function? Function is nothing but a block of code which will run only when we will be calling that function. So whenever that function is called, that function will execute, but before that it will not execute. Fine. It's a block of code which will execute only when it will be called. If it is not called, then it will not get executed. Okay. So we have called our function and we have saved it here. And after that, what we want to do? We want to print m, the value of m. Let's see what happens here. Control X is used to exit our file. Yes, we want to save it. Enter. And we will execute our file using Python 3 command. And we can say concept.py. What file we want to execute? Using Python 3 concept.py. It has given us 30. Now how it is giving us 30? Let us understand it. Okay. So nano concept.py. We have this, right? Inside it, what is this? This is just a function. This is a block of code which will execute whenever we call our function. And we have called our function. This is nothing but calling our function. This is how we call our function. Function name. Inside parentheses, we will pass some argument if we want to pass. And it takes 2 arguments. So we will pass 2 arguments. This is parameter which is defined inside our function definition, and this is arguments. We will pass our 2 arguments. Fine. And we will pass our 2 arguments here, and we will give this function. We will assign this function to m. M is a reference variable which will be having the value of this function. Whatever it will be returning the value. Now we will print this value. So this is how it is happening. Add is calling the function. We are calling the function add. 10 it is passing to x. 20 is passing to y. Z equals to x plus y. This means that first 10 will pass here, then 20 will pass here, then they will add themselves 10 plus 20 30, and it will pass here it to z, and then it will return z, means 30 will be returned here, m will be storing 30, and it will be printing 30 for us. This is how a function works. Fine. Now understand this. What do we mean by pure function? This is just a function. Okay. Now what do we mean by pure function? This will also act as a pure function. So we have functions, and some functions may be pure functions, some function may not act as a pure function. What do we mean by pure function? Pure function in simple language is just if it is given some value, it is given some input, it will give us the same output every time we give the same input to it. For example, we have given 10 and 20 to our function. Now every time we will get the output. What output we will get? We will get only 30. Every time we will give input to this function 10 or 20, it will send us output as 30. no matter who is sending and when it is sending. If it is sending 10 and 20 only, it will give us 30 only. No change in the output will happen if we are sending the same input. But pure function also says that it does not change, it does not have any side effect. What do we mean by side effect? Means if we do something to this function, it will still give us the output. It will give us the same output. Now let us understand what is not a pure function. What do we mean by that? Some functions are pure functions, some functions are not. This is a pure function. It will give the same output whenever we give the same input. If we give 20 and 20, it will give us 40 every time we give it 20 and 20. This is called pure function. And now also there will be no side effect. If we do something here, if we print something like hello world here, and we will be returning that hello world, it will be giving us hello world every time we give 10 and 20, and it will be storing here 10 and 20. If we have some line added here hello world, and we are saying that we want to return z and hello world, it will be returning hello world and z, a value of z every time. We are doing something here, but nothing is changing, so it has no side effect. Any function which does not have any other side effect on the value returning value that has been output, also if we give the same input, it will return the same output, and it does not show any side effect on that, that is called a pure function. What do we mean by if a function is not a pure function? Let's understand that. Okay, let's understand that. So for example, we have a global variable. What do we mean by global variable? This is a local variable. This is local to this function. This z is local to this function. We cannot print z outside the function. This is a local variable. Global variables are those variables which can be accessed from anywhere. If we say print, if we do here y, print y, this value will get printed, not this value. This value will get printed, right? So this is a global variable. We can say global variables equals to 50 if we do, right? And in this function we do some changes. We don't want the value of y, we want the value of y to be taken from this global variable, right? And we say to access the global value, what we have to do? We have to define here global. Also we can access it without defining global. Fine, we can say we want to return y, it will return y, no problem. We will understand this in function, no problem. What it follows? It follows, it first checks inside its function, inside the local variable, then it checks inside this. If there's another function, it will check inside that function. If we have nested function, it will check inside first function, it will check then the function above it, then it will go outside and it will seek for the global variable, and it will print that, and it will take that value and it will print that. If we will be returning z here, right, if we will be returning y here, in place of z we will be returning y here, right? Then it will be taking value from here. This function does not have any local variable y here, it will be returning y here. But right now I want to make you understand what do we mean by pure function. What is not a pure function? Let's understand that. So to access this global variable, but if we do some changes to this global variable and without defining global, what will happen? If we say y equals to y plus equals to 1, we are changing the global variable without defining it as a global variable. It will not try to find out outside it. It will throw us error. Why? Because it says that no y has been defined. First, you need to define y to add it to y. So when you declare global variable outside y equals to 50, and it can be accessed from anywhere, and you say in define my function name is add, and inside it we have x parameter, one parameter, it will be passed here, and we say y plus equals to 1. This means y equals to y plus 1, means here we don't have any local variable y. We can access it from outside, but we cannot modify it. If we do something like that, it will throw us error. Okay. If we do python c concept dot py, it will throw us error. No local variable has been found. Right? So before referencing it, before assigning it some value, we have to have some reference variable y, which we will be adding. What value we are adding? It did not find out inside a local scope, inside a function. Okay. Nano concept.py. So what will happen? To access this y variable, we will say global. Inside this function definition, we can say global y. We are declaring that now use this y, this global y, which are outside your function. Use it and give us the output. Okay. Indentation is very necessary in Python so that our compiler could understand. Okay. So we have this y equals to 50. This is a global variable. Inside a function definition, we said I want to take the global variable, value of global variable, and we will say we will add 1 to it. Fine, we will increment it by 1, and then we will return x plus y. If we are calling it 2 times with the same input, it will be returning different output. Let's say, for example, we say n equals to add, and now also we are saying we will be passing 10. It should give me 60, right? Print and first call this function and give 10 to it and print it, and then give add, then again call 10 with the same input. We want the same output, but it will not give us. Control X, yes, enter, and then we can say python c concept.py. It should give me the same output, but it is not giving me. It is giving me different output for the same input. So this is not a pure function. This is what we mean by pure function. So it encourages us to follow pure functions. What? Functional programming language. We were there, right? So functional programming language asks us to follow pure functions, to write our functions in pure functions. Okay. It is advisable to write our functions in pure functions. What happened here? It has called global variable y. It has not. We have explicitly this given it that we want the global variable y. We don't want the local variable. First, it has been added to this global variable. 1 has been added to this global variable. Now, value of y is 51. Return this 10 plus 51. What is 61? Again, we have called this function. Again, 10 will be here, but this time the value of y will remain here only. It has called earlier global variable, right? So it will remain here only. But we have explicitly decided that I want value of x should be 10, right? So now it will 61. It will add to it. It's 51, it will add to it 1 and it will become 52. And now 52 plus 10, this means 62. Right? Same input but different output. This is not a pure function. This is what do I mean by pure functions. In functional programming, we write our programs in pure functions. It is advisable to write our programs in pure functions, right? Which should give me the same output if we give it the same input. This is what pure function is. Functional programming also says treat my functions as first class functions. What do we mean by this? First class functions, this is meant by that we can assign a function to another function. Let's say, for example, in this is a function, right? This is a function. If we are able to assign it to another function, then that will be called first class functions. This is called first class function. It has treated it as a first class citizens. We can say D is a function, right? D is a function which will store, D is a reference variable which will store this add function. Add function. Inside it we will pass 10, right? So we have assigned it to another function. And this has now become functional reference. This is function. This has become itself a function, right? So this is called, this is what do I mean by first class functions. What do we mean by first class functions, right? So this is functional language. And what do we mean by object oriented language? Object oriented language uses classes and objects to write a program, right? It uses classes and objects to write a program, to write a whole program. We use classes and objects. What do we mean by classes? What do we mean by object? Class is nothing but a template. Class is nothing but a template. And what is an object? Object is an instance of a class. What is an object? Object is an instance of that class. Class is just a template. For example, we all belong to human class. We have 2 ears, 1 nose, 2 eyes, right? So this is the class template that has been created by God. And now, using that class template, we have different humans. For example, Ajay, Rahul, Megha. They are different humans. They are nothing but an object of the human class, right? And they have their unique capabilities also. Every object has their unique capabilities also. So that is what a class and object is. So we will be having a class in our program through which we can create different objects, right? And that different objects can have their unique property or can have that same property as their class. Okay. So this is what do I mean by class and object. Class is the named group. It's a named group of properties. We have different properties inside a class and functions. What do we mean by properties? Properties is nothing but the variables, the reference variables, its value. These are the properties. And what do we mean by function? Functions, I have told you, is a block of code which will be running whenever we call it. That is a class. That is the definition of class, named group of properties and functions. What is an object? Object is an instance of a class. And we can have as many objects of a class as we want, and we can create it as unique as we want. Two objects cannot be similar. It's not compulsorily similar. They can be similar, but they are not compulsorily similar. They can have their own unique qualities also. Ajay has different unique qualities and Ram has different unique qualities, right? So these are two objects of the human class and they have their own unique capabilities, right? So this is called object oriented programming. This is what do we mean by object oriented programming. So in high level languages, what are the procedural language? Let's understand it. So Java is a procedural language, C is a procedural language, C++ is a procedural language, right? And Python is also a procedural language, right? Functional language, what are functional languages? So in high level language, Python is a functional language, right? And what are object oriented languages? So basically, C++ is a object oriented language, Java is a object oriented language, and Python is also an object oriented language, right? Okay, so these are, so it means that one high level language can be of different type. Yes, they can be of different type. For example, Java is a procedural language. Java is also what? Object oriented language. C++ is an object oriented language. C++ is also procedural language. Python is a procedural language. Python is functional language, and Python is object oriented language. So one language, one high level language can be of many types, of many different types of high level language based on how we write a program. This is the type of high level language based on how we write a program. Now there's another way to differentiate between different types of program. So we have different types of high level language based on its type. So there are different types of high level language based on its type. What type? Data type. What type are they? So in this way, there are two types of typed languages. One is static language. One is static language. Another one is dynamic language. So these are based on the typed language. Dynamic language. Okay, so one is static language and one is dynamic language. What do we mean by static language? Language in which type checking is done at compile time are known as static language. So type checking is done at compile time. What do we mean by type checking? Okay, so type checking is done at compile time, right? So in a static language, type checking is done at compile time, while in dynamic language, what happens? Type checking is done at runtime, right? So in a static language, what happens? In a static programming language, what happens is type checking is done at compile time. So during compile time, type checking is done. But in dynamic languages, what happens is type checking is done at runtime. What type of variable is that? Is done at runtime in dynamic language. What is this type checking? So type checking is nothing but checking the type of the variable to which our value has been assigned. And what is this compile time? Compile time is the time when we write a program, right? And we send it to the computer. So compile time is the time when computer converts it into zeros and ones. This is the compile time. Now what do we mean by runtime? So runtime is the time when our program has been converted into zeros and ones. Now it's time for our program to get executed. This is called runtime. Compile time is the time when we convert our program into machine code, into zeros and ones, because computer only understands zeros and ones, and we have to convert it into zeros and ones in order to make computer understand, right? And we do it using compiler. So compile time is the time when our written code, our English language written code has been converted into zeros and ones. And runtime is the time when this already converted code, zeros and ones, is executed in our system. This is called runtime. So when type checking is done at compile time, it is called static language, and when type checking is done at runtime, this is called dynamic language. Okay. In static language, what happens is, so when you type check something, for example, if you say a equals to 10, and in this in a static language we have to define our data type before the variable, while in dynamic language we don't need to define our data type before the variable. We can, in dynamic language, we can directly say a equals to 10. In a static language we have to define our variable's data type. We have to say this is an integer, take integer value only. But in dynamic language we do not have to say that this is an integer, take the integer value only. It will, computer automatically finds out that what type of value is this and what data type will it be during runtime. This is done at compile time. So for example, if we do some mistake here, if we say int a equals to 10, now we assign it int a equals to Rahul. Now what will happen? It will throw us error in static language. Why? Because it is saying you have defined it for int, you have said that a will contain int value only, integer value only, but you are defining that I want to store string value. You cannot do that. So this is wrong. So it has done type checking at compile time. It has not converted our programs into zeros and ones. During compile time only it said this cannot happen, it will throw error during compile time only. But in dynamic language what will happen? A equals to 10, it will said okay, good to go, and it will print the value of a. But for example, if we say that a equals to, in place of a we say a equals to Rahul, and what we try to do, we define b equals to 20, and now what we are trying to do, a plus b. Now this will throw error during runtime. It will say that you cannot add a string to a variable, to an integer value, right? So it will check this during runtime in dynamic language, right? But in static language it will check at compile time only. It will not convert a program. This program has been converted, just that during the runtime when our operation was performing, it said we cannot do this, we cannot perform a plus b. Why? Because we cannot add a string to a integer value, and it will give error during runtime in dynamic language. What is the advantage of static language? Static language gives us more control, right? We have more control over this, over our coding, over what we can write. We have more control. But in dynamic languages, what happens it gives us less control, right? And we can save time by writing. We can save time by writing our code, because we do not have to write int, we do not have to define its data type. So we may save time for now, but it may give error during runtime. So it may become problematic for us. So that is about static language and dynamic language. Now we will be understanding about memory management. Okay. Now we will be understanding about memory management. So what happens when we write a equals to 10? What happens? Let's understand this. What is this a? What is this 10? Let's understand this. So a is the reference variable and 10 is the value that a is pointing to. So there are different types of data types. So we have different. So in memory management we have two types of memory. right? We have two types of memory. One is called stack memory, another one is called heap memory, right? One is called stack memory. We have two types of memory. In memory of a inside a computer we have two types of memory. One is stack and one is heap memory, right? So when we say a equals to 10, this a is the reference variable and 10 is an object. In Python is an object oriented language, and in object oriented language what happens is, this is the reference variable and this is the what object. 10 is the object, a is the reference variable, which is pointing to the memory address of this 10, and a will get stored here in the stack memory, and this is the reference variable which will get stored in the stack memory, and this is the object, it will get stored in the heap memory. All objects get stored in the heap memory, right? Whether it is primitive or not, it will not give any difference. It will store here, this reference variable will store here only, and this object, whether it is primitive or not, it will still store here, because in Python everything is an object. Every primitive or non-primitive data type is an object, right? So when we say a equals to 10, so what are primitive and non-primitive data? What is a data type? Data type tells the type of the data. And what are primitive and non-primitive data type? So primitive data type are those data type which cannot be broken further, which we cannot divide further. And non-primitive data types are those data types which can be divided further. For example, int is a primitive data type, whereas list is a non-primitive data type, right? Int means integer values. We cannot divide integer values. 5, we cannot divide 5, we cannot divide 6, we cannot divide 7 in further data types, right? But in list, we have a list. List is defined by this, right? So inside it we have 1, 2, 3, 4, 45, let's say. And we can divide it further into integers, into individual integers. This can be divided into integers, this can be divided into integers, this can be divided into integers. 45 can also be divided into integers. So these can be divided into further data types, but primitive data types cannot be divided into further data types, right? First thing is that what is data type? Data type tells us the type of the data, and there are two types of data type: primitive data type and non-primitive data type. Primitive data type are those data types which cannot be divided further, whereas non-primitive data types are those data types which can be divided further, right? Whether our data type is primitive or not, it will store in the same way. Reference variable will get stored in stack memory, and our object will get stored in the heap memory. If it is a primitive data type, still it will be called as a reference variable, because it is pointing to an object, and everything that is pointing to an object is called a reference variable, right? So whether we say a equals to 10 or we say b equals to, we give some string value, right? So we can say b equals to Rahul, or we can have list c equals to 1, 2, 3, 4. We have a list. All a will be stored here, b will be stored here. B is a reference variable, it will be stored in the stack, right? C will be stored here, it will be stored in the stack. And this Rahul is an object, so Rahul will store here, right, in the heap memory. In the same way, we have what? We have 1, 2, 3, 4. This will be stored in the heap memory because it is an object. It is an object, right? And this reference variable will be pointing to the address of this object. So what will be doing? A will be pointing to the object B will be pointing to its assigned object. C will be pointing to its assigned object. Right? So this is how it works. This is how memory management works. This is our stack memory, this is our heap memory. And this string, this also stores in something known as string pool. Inside this heap memory, we have a special string pool which will store this value, this string value. We will see it further in string class. Right? So that is about stack and heap memory. Also, earlier what we have done is we have assigned A to 10 and we then assigned A to Rahul. Now let's understand how this works. Right? If we say A equals to 10 and then we say A equals to Rahul. Okay? Let's understand how it works internally. First, A will be pointing to 10. Right? A will be, when we assign A to 10, 10 to A will be pointing to this 10. Right? But then after some time, when we assign Rahul to A, now what will happen? This pointer which is pointing to 10 will get deleted. It will now not point to 10. It will now point to Rahul. Rahul object. This A reference variable will now point to Rahul object. Right? So this is what happens. And what will happen to 10 then? So this 10 will be removed from the memory. And if this is an object, it will be removed by the garbage collector. So it will go into the garbage collector whenever garbage collection hits. And it hits automatically whenever a RAM decides that I want to free up my memory. It will hit the garbage collection and it will remove from the memory. It will be removed from the memory. This is what happens to this value, which has, so any object which does not have any reference variable pointing to it will get removed from the memory whenever garbage collection hits. This is what happens to this. Right? Also, one more thing to understand is that if we have something like A equals to 10, right? And we are now saying A equals to, we are saying B equals to A. We are assigning B to A. B reference variable to A reference variable, and it will be pointing to 10 only. See what happens. We have A, we have B, right? And we have 10 here somewhere, right? And we say A equals to 10. Now A will be pointing to 10, right? Then we say B equals to A. Assign the value of A to B. So now B will also be pointing to the same object. So two reference variable can point to the same object, right? And if it's a variable whose value, whose elements we cannot change individually, if we cannot change this element's value, this reference variable's value individually, then if we do some changes with here or here, it will not reflect in other variable. For example, if we say I don't want A equals to 10, now I want to say A equals to 20. Earlier we had A equals to 10, but after some time I want to say A equals to 20. Now it will not reflected here in B. This will not be reflected here. Why? Because we cannot change individual value. We have to change the whole value. We are changing the whole value of 20, right? So it will not be reflected in B. So what will happen? Now A will not point to 10. A will now point to 20. Right? A will now point to 20. This is what happens. B will be pointing to 10 only. It will not change the value of B. If we have changed the value of A, it will not change. In the similar fashion, if we say in place of B, I have assigned A to 10 and I have sent B to A. But now I say that I want to change the value of B, I want to change it to 20. Now what will happen? So I said, this is not here. I said, I have assigned A to 10. This is also not here. This is also not here. Right? Now what I said A will be pointing to 10. A will be pointing to 10. Right? B will be pointing to A. B will be pointing to A. Right? But now I said I don't want this. I don't want this to point here. I want this to point to 20. Now it will point to 20. It will point to 20. Right? If we change the value of any reference variable, it will not get reflected on another reference variable when we cannot change the individual element of an object. We are changing the whole element of that reference variable. Right? But for instance, let's say that we have something known as A equals to, we have some list 1 comma 2 comma 3 comma 4, right? And we have another list B equals to B, and we are assigning B to A to B, right? In this case we are assigning A to B. What will happen? We have A here, we have B here, we have list 1 2 comma 2 comma 3 comma 4 here, right? And now what we are saying? We are saying A will point to 1 2 3 4. Then we are saying we are assigning B to A. We are saying in B will be pointing to this only, right? But now we can access individual element and we can change the value of it. Let's say what I do, in place of B of 1, I want to change the B of 1 value to 8. Now what will happen? This will change to 8. Right? So this is the index number. Index number in list, index number starts from 0. So this is 0th index, this is first index, this is second index, and this is third index. So we are saying I want to change the value of first index to B reference variable. So B of 1 equals to 8. This will be changed and it will be reflected to each reference variable pointing to that object. Pointing to that object, each reference variable will, values will be changed for each reference variable. Right? This is what happens when we can access and change individual value of any reference variable, individual object of any reference variable. This is what happens, right? So this is about memory management. Okay, now we will be learning about flowchart and pseudocode. Flowchart and pseudocode. What is a flowchart? Flowchart tells us the visualization of a thought process. Means how we visualize our thing. It tells us that. And what is a pseudocode? Pseudocode is just a rough code. Pseudocode is just a rough code. Now, there are some elements through which we can describe our flowchart. There are some shapes through which we can describe our flowchart. Flowchart is like a chart, right? So, for input and output, we have something. For start and stop, we have something. For processing, we have something. For checking condition, we have some shape. And for checking the flow of program, we have some shape. So these are different. These are represented by different shapes in flowchart, right? Input and output is described by parallelogram, right? So we can put our input and output inside parallelogram. Start and stop, we will put start and stop inside oval shape, right? And we will put processing inside rectangle, right? And we will put our condition inside rhombus. So we have here, I did not find my shape, this inside rhombus, and flow of program will be shown by this, and flow of program will be shown by this, right? This is where our flow of program is going. This is, so this it is shown. What do we mean by input output? Input output is if we are taking some number from the user, that is the input. We have something, we are taking something from the user, that is the input. We are giving out something to the user in the display, that is the output. We are starting our program, that is the start of our program. We are stopping our program, that is the stop of our program. We are doing some processing, we are doing addition or subtraction or multiplication or division. We are doing something with our input and output. We are with our input, then that is called processing. What is condition? Condition is to check whether a condition is true or not. For example, we have two children, and both have scored 91 and 92. Now who has greater marks? We can check it inside condition. We can put some condition here. Flow of a program is shown by this arrow key, right? This ray, right? So this is flow chart. These are the elements of a flow chart. Now we will be drawing a flow chart. So our question is draw flow chart and write pseudocode for taking name from user and printing it. Okay. So what we have to do? First we have to start and stop, right? Then we will copy this. We will do this, right? Then we have to copy the flow. We have to set the flow of a program. So here it starts, right? It starts, right? Then we will input name. We will input name, right? Then we will output name, right? And then we will stop our program. Stop our program. Now for inputting name, we will use this. We will use this. For output name, we will again use this, right? And to stop, we will use this. We will use this. We will use this. What is the flow of our program? So we have to draw line. First, a flow of program is from here to here. Then a flow of program is from here to here. And then it will go from here to here. This is simple flow chart of our question. Also, we can write pseudocode for it, pseudocode for it. Pseudocode is the rough code. We can start a program, right? And then what we'll do, we will input name, we will output name, and we will stop our program. This is simple pseudocode for it, right? This is simple pseudocode for it. Okay, so that is about pseudocode and flowchart. Now, what we will be looking? We have looked what is a programming language, its types, okay. Memory management concept we have understood. Flowchart and pseudocode we have understood. So what is the use of Python? Python is used to create software. Python is used to create for web development. It's used for web development, right? Website development. Python is used to do data analysis. In data science, it is mostly used for machine learning, for many different things, because it has function inside it, and function can be called as many times as you want, right? So that's why we use Python in machine learning. Okay, so that is the use of Python. So we will be creating a file in AWS, Amazon Web Services. We will be using EC2 service of that, and we are creating a file in Ubuntu using nano command, right? And then what is the version of a Python? It is 3 point something, 3.10, right? So earlier we have checked Python. We are all using Python 3 hyphen version. What is the version of a Python? So we have 3.10.6. 3.10.6, right? So this is the version of Python. Okay. And Python file extension would be .py, right? Now what do we mean by indentation? Indentation is basically we are telling our Python that this is inside this function, that anything we type here x equals to 10, this is inside our definition, our this add function. So this is called indentation. If we don't do that, if we say we will put x here, it will not say that it is inside this function. It will say x is some different variable that is not inside this function. It will throw us error. So this is called indentation. Indentation is very necessary in Python, right? To tell our to tell the Python that we are putting it inside our function, right? Now we will be looking how to output something to the user. Also, we will be looking at the comments, how to comment anything, right? So one thing, how to output. So we can use print function to give output to the user. Print function, anything we type here, we say inside it I want to print Bharat, right? And we have to put a string in double quotes, right? We can say Control X, yes, save, enter, Python 3 content .py, enter, Bharat has been printed on the terminal, right? So print function prints our value that is given inside it, right? Nano content .py. Okay. Now comments, there are also comments. What is a comment? Comments are ignored by the compiler. For example, we say good. We do something here, and above it also we put some comments. We put some comments, right? And we say Control X, yes, save, enter, and now we say Python C content.py, enter. It has ignored the comment. It has not printed the comment, right? So what is a comment? Comments are ignored by the interpreter. The interpreter do not execute the comment, right? They are ignored by the interpreter, and we can put it for enhancing the readability of our program, right? This is comment, and we can define comment using hash only. For multi-line comments, we can again use hash on each line. For example, we have two comments here, so we can say hash, and we can again comment it. For multi-line comments, this will happen. Okay, so this is multi-line comments. So we have understood comments and output. Now, what are variables? Variables are used to store data values. Variables are nothing but just a container for storing data values. Okay, so we can create variables by assigning it to some values in Python. For example, a is a variable and we have assigned it 10. This is a variable. A is a variable and we have assigned it some value. Variable is a container which stores some value, right? So a contains some value. In the same way, b equals to, we can say cat. Now this is a value, this is a variable. Variable is nothing but a container for storing data values. In Python, because it follows object-oriented programming principles, OOPS concepts, so this is called a reference variable and this is called an object. This is an object of string class. This is an object of int class, and this is the reference variable referencing to this object, pointing to this object. This is variable in Python, right? We can create variables by assigning it to some values. Also, we can create variables like c comma d equals to, we have to assign two values because we have two variables, so we have to assign two values by separating them with commas. We can say 50 comma 60. Now two variables has been created, c has been created, d has been created, right? If we print these variables, we can print it directly inside print function. We can say a comma b comma c comma d. In print function, this comma means a space. Okay, we can say control X, yes, enter, Python 3 content.py 10 cat 50 60. It has been printed. A has stored this, B has stored this, C has stored this, D has stored this value. And they are all objects. They are stored in the heap memory. They are stored in the heap memory. So earlier we have discussed, right? Earlier we have discussed that we have two memory inside our system. One is stack memory, one is heap memory. So A, B, C, D are stored here in the stack memory. These are called reference variables and they are pointing to the objects. And what are objects? What are objects in this case? 10, cat, 50 and 60. These are objects, right? So these are objects, these are stored in the heap memory. And reference variable is pointing to the object in the heap memory, right? So that is about variable. Okay, we can create it. I have told you how to create it. We can assign again. Inside it, we can say content.py. We can also create our variable by assigning it the same value. For example, if we say e equals to f equals to 100, right? And we print e and f also. Control X, yes, enter. We can say Python 3 content.py, enter. Now 100 has been assigned to these two, e and f, right? So this is how we can create a variable. We can also unpack a tuple inside a variable. For example, there's a tuple. There's a tuple like this. So tuple is defined by round brackets. So there's a tuple 45 comma 65 comma 76, right? This is a tuple. We can unpack it inside our variable. We can separate it inside a variable. We can assign it separately to a variable. We can say to m comma n comma f n comma m comma o. We give this 45 65 76, and we will print it, right? We will say print this m comma n comma o, print it, right? And we can say control x, yes, enter. Now if we print it, what, this python 3 content.py, it will get printed 45 65 76. So we have unpacked our tuple inside a variable, right? Also, this variable name is case sensitive, means small a is different from capital A. Small a is different from capital A. If we say capital A equals to 3, this is different. This A is different than small a. Variable name is case sensitive. How we can create variable name? How to define a variable name? So we can define a variable name by only using characters, underscores, and numbers. And it should be started with underscore on or characters, right? It cannot start with a number. It will only start with underscore and characters, letters, alphabets, right? So we can create it, right? We can check the type of the variable. We can check the type of the variable. How can we check the type of the variable? We can say type of, which type we want to check. Type of, we want to check, for example, a, right? We want to check the type of a. We can say type of a, print the type of a, right? We can check the type of the variable using type function. Enter. Say this first thing is of class int type, right? So it is of int type. We can check the type of the variable using type function. So case, they are all case sensitive. Capital A is treated differently than small a variables, right? We can unpack a collection in a variable. We can unpack a list. We can unpack a tuple also. And there are different ways to output variables. Okay, so we can output our variables. Earlier, what we were doing, if we say nano content.py, what we were doing, we were printing it by using comma. We can print it by using plus sign. But in integer, it will add it, and it cannot add a string and an integer. It will either add both integer or it will print both string. We can add it, right? We can say a plus c. Now it will get added. It will get added. This got added. 50 plus 10 means 60 got added, right? We can clear this out by using clear command. We will again open a file, and here this has been added using plus command. Also, we can join two string using plus command, right? For example, we have something like m. For example, we have something like z equals to hello, right? And we want to join these two, hello cat. We want to say hello cat. We want to print hello cat, right? How to print hello cat? We can say z plus B, and we can print it. Control X. Yes, enter. Now it will concatenate these two strings. See, hello cat. Now it has not given us any space because it will not give us space. We have to define it separately. We can say nano content.py. We can say I want a space in before in this joining of two strings. So we can say plus inside it I want a space, and then we can concatenate it, right? We can say control X. Yes, enter. It will print it, right? Now it has printed the space, white space has been included. So this is how we concatenate a string. So there are different data types in Python. There are primitive data types, there are non-primitive data types. Primitive data types are those data types which cannot be broken further. Non-primitive data types are those data types which can be broken further. Right. So int is a primitive data type. We can say int means integer value. We can say int 30, a equals to 30. This is how we define integer value inside a variable. So this is of int data type. Right. B equals to 45.67. This is of float data type. Means float data type contains decimal values. Right. Also we have something known as what? String data type. String data type contains string. So it's what is a string? A string is a combination of characters. One or more characters. So string is also a data type. Then we have Boolean data type. Boolean data type, for example, D equals to true. Boolean data type stores true or false or 0 or 1. Right? Then 0 means false, 1 means true. Then we have another data type known as complex data type. E equals to, we can say A plus, not A, real number, right? 50, 56 plus 56 plus 5J. J is the imaginary number. This is the complex data type. Right? J is an imaginary number. In maths, imaginary number is under root of -1. Right? So that is an imaginary number. So this is the complex data type. Right? Then we have list. List data type. F equals to. List data type can be defined using this. We can have list values 56, 67, 87, 98. Right? So this is list data type. We have another data type known as tuple. Tuple data type. So we can define tuple data type using round brackets, and we can have some values inside it, some elements inside it. Right? This is tuple data type. Then we have set data type. G, E, F, G, H. H equals to. We have set data type. Set data types using are defined using curly braces. We can say 67, 98. It cannot contain what? Duplicate values. Set. They're just like a math set. Right? And then we have dictionary. I equals to, we have dictionary. It is also defined using curly braces. Right? It has key value pair. We can have a key. For example, we can have dot, right, equals to. Now this is key. Dot is a key. Now we have to define a value. Inside value we can have good, goof. Right. So this is key value pair, and we can have different elements inside it. We can comma. Using comma we can separate it. Right. We can say, okay, we don't have to put equals to. we have to put colon here, colon, right? We can separate it using comma. We can say now another key we want to create is happy, and inside it we want to create a value as boy, right? So happy is our key, boy is our what? Value. This is our key. This is our value. So dictionary data type, this is dictionary data type, right? This is dictionary data type. So these are different data types that is inside Python. We have we have integer data type, we have float data type, we have string data type, we have bool data type, boolean values, it contains boolean value, true or false, it just returns true or false. Then we have complex data type, then we have list data type, then we have tuple data type, then we have set data type, and then we have dictionary data type, which contains key value pair, right? So this is about data type. These are the different data types that is there, right? So these are the different data types. We can cast it using casting. We can cast it using casting. We can say, okay, let's say I don't want all this. Let us understand the concept of casting. We can say a equals to 30. If we print this, right? If we print a inside our print function, control X, yes, enter. We want to print this, right? It will print 30. It will print the integer value. This of what type? We can check this is of what type using nano content.py. Inside it, we can check the type of it. Type. What type of variable is this? Control X. Yes, enter. So this is of int class type, right? We can but cast it into float. We can cast it into float. We can say I want it as a float. So I can say float, make this value float. This is called typecasting. We have casted it into floating value. Now if I check it, right? If I check, this is of float type. Earlier it was int type, but now it is of float type, float class type, right? So we can cast it into another type. We can cast one data type into another data type, right? We can cast one data type into another data type. So this is called casting. Casting is nothing but conversion of one data type into another. For example, conversion of integer value to floating value. How we can do it? We can do it by putting float before it. We can do it by putting the type of that before it, before the value. We can do it in the case of integer using int. We can do it in the case we can convert anything into float using float. We can convert anything into string using string. We can convert anything into list using list. We can convert anything using into tuple using tuple. Right, tuple keyword, tuple. Right. So this is how we do casting. Now, how to take user input? How to take user input? We can take user input using input function. We can say input. It will input from the user. But we want to print some message for the user. We can say enter a number. Right? Enter a number. Input, enter a number. The user will input and we will print that number. Print. Okay, we have to save it somewhere so that we can print it. Right? We will save it into A. Okay. And now user will input a number and we will print it. We will say A. print A, control X, yes, enter, Python 3 content.py, enter number, user had entered 4, now 4 has been printed. But this is of which type? This is of a string type. We can check it. Py. We can check it. We can check it here. Print type of a. Type of a. Type of a. Control X. Yes, enter. We can say. So enter number 5. Enter. This is of type string class. It is not taking integer value. Input function only takes string value. Input function will only take string value. Right? So how can we convert into int? Using typecasting. Using casting. We can cast it. We can say input this number and cast it into integer. And cast it into integer. Right? And cast it into integer. Control X. Yes, enter. Now if we say python.content.py, it will, okay, we will take some number. This is of int class data type. We have casted it into an integer value. In the same way, we can cast anything into floating value or anything into string or into list. We can cast it. Right? So this is how we take input from the user, and it is given in a string only. We can cast it using anything from one data type to another. Now, what do we mean by global and what do we mean by local variables? Now we will be understanding what do we mean by local variable and global variable. Right? So, variable, any variable which is inside our function is called a local variable, and variable which can be accessed from anywhere and it is outside a function is called a global variable. Local variables are those variables which can only be used by that function only which is in which it is inside. And what do we mean by global variable? Global variable can be accessed from anywhere and it is defined outside the function. So in this case, X is a local variable, Y is a local variable, and Z is a local variable because it is defined inside a function. Right? This is a function, this is a block of code which will only run when we call it, which will only execute when we call it. Right? This is X, Y, Z. These are local variable. If we define something outside a function, it will be called what? Global variable. For example, if we define S equals to 100, this is called global variable. S is a global variable. It can be accessed from anywhere. We can print S also. Right? We can print S. Right? Control X. Yes, enter. Print it. X comma Y. Okay, so this was expected. We have to put it after we have defined a function, right? So we can say no. What? Content.py. Right? So in the function definition, we have to put colon also, right? Now we will execute it. It got executed. We have 30. We have added 20 plus 10 and it has accessed 100, right? It has accessed global variable, right? Now let's nano again content.py. So this is global variable which is defined outside the function which can be accessed from anywhere. This is local variable which can only be accessed within the function and it is defined inside the function. This is local variable, this is global variable. Right? Now How a function can access a global variable? It can access it directly, right? If we, for example, don't have y here and we don't have y here, we want to say x plus s and we want to return it, right? And we don't want to call it, we want to call 10 only. We want to call, right, like, okay, we want to call 10. 10 plus 100 means, so what will happen when we call, so I don't want to print this extra, okay. So when we call this add of 10, it will go here, 10 will save to x. Now z equals to x. X means what? 10 plus. It will find it here only. It will find a global variable, a local variable here only. But s is not defined here. Now it will go to the global variable and it will say give me s, value of s. So it will give, okay, take the value of s from here and now it will get added and we can say return z. Now it will go here, it will come to m, z will be stored to m, the value of z will be stored to m and we will print m, right? Let's see how it works. We can directly access global variable inside a function, right, when the 10 has been printed, right? This was about local variable. How can a function access global variable? But if we do some changes to our local variable without defining it, then it will not be able to. If we do some changes to the global variable without defining it inside a local variable, then it will not be able to get it. For example, if we say s equals to s plus equals to 1, this means same as s plus 1, right? S equals to s plus 1, right? So what it is saying, it is saying do what? S equals to s plus 1, right? So it is saying add 1 to s and then assign it to s. But it will say there is no s available in the local variable, in the local function. So how can I add it to it? Add anything to it, and how can I assign it to it? Anyone? So if we try to modify it without accessing the global variable, if we directly modify it inside a function, it will give error to us. For example, if we say return s, means I am incrementing the value of s. I am saying return s without defining that I want to increment the value of global variable, right? We cannot access it like that. We cannot modify the value of global variable directly. Earlier what we were doing, we were using the value of global variable. In x plus s, what we were doing, we were using the value of global variable. S was 100 then, so we were using it inside add function. We can say z equals to add 10 to 100. We are not modifying the value of global variable. But when we are trying to modify the value of global variable, what will happen? It will throw us some error. Now let's see how. So before that I don't want to pass x here. I don't want 10 here. I want to print it, right? Control X, yes, enter. Now if I try to execute it, it will give me error, right? No local variable was found, okay? So how can I change the value of s if there's no local variable found, right? So we cannot modify the local variable directly. How to modify the local variable, value of local variable? We can define it explicitly that this is our local variable, right? We can say that as is a global variable. Sorry, I said local, but as a global variable. So we can explicitly say that global S, I am referring to global S. Okay, we can say global S, then do this S plus 1. Okay, then do this. I am referring to the global variable S, and now I am saying add 1 to it and assign it to S. Now if I will return here, control X, yes, enter. Now I will be able to access global variable. And nano, I said nano, control S, yes. Okay, now I want to execute it. Python say content.py. Indentation error. So some indentation error may occurred. So Z10 was here, right? So Z10 should be below it. So see, this gives us error. A small white space will give us error like this. Okay. Control X. Yes. Enter. I want to execute it. Right? 1Z1. Its value has been incremented. We cannot modify global variable directly without defining as a global variable. We can use it inside a function, but we cannot modify the value of global variable. Right? So that is about global variable. We can access local variable outside if we have defined it as global. Right? We have here we don't have s as a global variable. We have s inside this. Right? We have s inside this. S equals to 100. Right? To access it outside the function, to access our local variable outside the function, what we have to do? We have to declare it as global S, global variable. We can say global S, this our variable is global. Now we can say this is our value of S and we can return it, right? If we call it, it will be returned. Here it has been called add and then it has been returned here in M, and then we can print our S, and then we can print our S value, right? But you must be questioning that why to call this? Why directly not print it? But let's print it. Control X. Yes, enter. We can say Python 3 content.py 100. It has accessed a local variable. The function outside it has accessed a local variable. Right? Using global keyword, which we have defined inside our function. Right? So that was about local variable, but we were understanding one more thing. So what we were understanding, what we were trying to understand is that why we have called this. If we haven't called it, what will happen? It will throw us error. Why? We will understand it, right? Why this calling is necessary? Control X. Yes, enter. It has thrown us error, right? It has thrown us error. It hasn't found out where S is defined, right? Why it is throwing us error? Why calling the function is necessary? We will understand it. Why calling the function is necessary? We will understand it. Right? First, let me call it. Let me say m equals to add. Let me call it. Right? So what was happening here? Let us understand here. Alright. So what is happening there? Let us understand. So we have two memory, right? We have we have one stack memory, right? We have one stack memory and we have heap memory, right? So a function, when we write a function as def add def, okay, we want it small, def add, and then what we do, and then colon, and then what we'll do, we'll say global s, right? We have done it there, right? Now what we say, we say s equals to 100. We have defined s equals to 100. Then we are returning the value of s. Then we say return s, right? And outside the function, we are calling it, we are calling add, right? We are calling add function, right? We are calling add function. And then what we are doing? We are printing the local variables value, right? So this was happening, right? So now why this calling is necessary? Why can't I directly access it as I have defined it global here? Why? Because what happens to the function? So whenever you define a function, its value are stored inside this program only. It is not stored inside this heap memory, inside this stack memory or heap memory. This is stack memory, right? This is stack memory. This is the heap memory. Now when I say define add function, it will be stored somewhere, but not in the stack, not in the heap memory. It will be stored somewhere as a program, but it will not take any memory inside the heap, inside the stack, inside the heap. Now when we call this function, then what will happen? This is a function, right? It will be stored inside this stack memory. This add reference variable to the function, with this add function, it's stored inside our stack memory, right? And if it has a local variable inside it, it will be stored inside this stack memory only, right? We have a function and it, if there's some local variable, in this case there's nothing, but if we had some local variable, for example we had something known as x equals to 10, then it will also be stored here only, because it is stored inside the function, right? And it has been what called, whenever a function is called, that function is stored inside stack memory, and when that execution of the function gets over, when this has returned some value, when this functions is done performing its function, then this will go outside this stack memory, right? It will go outside this stack memory. So whenever we call a function, it gets inside our stack memory, it takes some memory inside our stack memory, and then when we are done executing our function, it will go outside the stack memory when its job is done, right? So what happened here in this case, we have add function inside our stack memory, right? We have add function inside our stack memory. It also contains its local value, local variable value. For example, x equals to 10, it contains, right? Now this global s, this has been defined in heap memory because this is global, right? This has been defined in heap memory. This 100 has been defined in heap memory, and s is pointing to this 100 from here, right? This was it, and s is pointing, now we will draw that s is pointing to this 100. Why it is pointing? Because it is a global variable. We have given it some global value. We have it has been stored in the heap memory because it is global variable. It can be accessed from anywhere, right? And when its job is done, these will get erased, right? But this will not get erased, means s will not get erased, right? S will not get erased. And this was stored, so when we called it, it was stored, this add function was stored inside a stack memory, and when it has returned s, then it is done completing its job. It has been popped out of the stack memory, released from the stack memory, right? But this s and its variable, this is a reference variable, this is the object of s, right? So this has been stored, in the heap memory, this has been stored in the stack memory, and now this global variable is now accessible for anyone, right? So we can access it directly outside the function. This is what happens in functions, in local and global variables. This is what happens, right? We have understood it, right? Local variable value will get stored inside stack memory, inside the function, if it is defined inside the function. Global variable and its value will get stored in the heap memory, that is the object, and reference variable will get stored in the stack memory. It is the global variable. It is same as like if we have earlier defined m equals to, this is outside the function, right? M equals to 100, so m will be stored here and 100 will be stored here, right? But in this case, this 100 will point to this here only. Why? Because from minus 5 to 256, from minus 5 to 256, these integer values will be point, whenever they are created, whenever we create new integer value in this range, it will point to the integer value which has already been created of the same name, of the same value. For example, we have created 100 here, so in this case m will also point to the same 100 object, it will not point to different 100 object, right? Inside this range. But if it outside this range, if it is beyond like 1440000, this is the number, it is beyond this range, right? Integer range. So it will not point to the same object, means there would be two 1440 and they will be created separately inside heap. These are two objects created separately inside heap. But in this range, if our integer value is in this range, then it will be pointing to the same object that has been earlier created, right? So that is about local and global variable, right? So that is about local and global variable. We have understood it, how function works, right? So to check if an object belongs to a class or not, okay, so we have a function known as isInstance. IsInstance checks whether a function belongs to a, whether an object belongs to a class or not. I have said it earlier that a equals to 10. 10 is an object and a is the reference variable. So I have to check to which class object it is, because what is an object? Object is an instance of a class. So this object has been an instance of such some class, right? So we can check the class of the object using isInstance function, right? We can say print isInstance. It will contain two value. Which object we are checking? We are checking a. And in which class we are checking? We are checking in integer class. We are saying that this a object is an instance of int class or not, right? It will return true or false. Control X, yes, enter. Now we say Python C context.py true. This is of type integer class, right? So this object is what? This object is of type integer, which it has been derived from where? This class, integer class, right? We can check it. We can check any object belongs to any class or not using isInstance function, right? Using isInstance function. To check if an object belongs to a class or not, we can use isInstance function. Size of int data type. So the size of the int data type is not fixed in Python, right? How much the size of the data int can contain, it is not fixed in our data type. It is not fixed in Python, right? So it depends on the RAM of the computer, RAM of the system. It can be of 4-bit, it can be of 8-bit. It depends on the RAM, right? So that is about int data type, and it can be of any size. Int data type can be of any size. That's why its size is not fixed, right? So it will not take constant value on every system, right? In some system it may take different value, and in some system it may take different value. So in that case, that's why Python is slow, because its size is not fixed. Its data type sizes, its int data type size is not fixed, right? That's why Python is slow. Also, one more thing to consider. When I said we have a equals to 10 and we have b equals to Rahul. Now if we do something like a plus b, it will throw us error. It will not convert this, it will not add this integer value to this string value. Why? Because it is a strongly typed language. So during the operation, it checks the type of both the variable, and if it finds out that they are not compatible, it will not print it. It will not execute that operation. That is why it is a strongly typed language. Strongly typed language are those language which checks type checking of each variable during operation, during an operation, right? So that is why it is a strongly typed language. What is an example of loosely typed language? C is a loosely typed language, right? C is a loosely typed language. It will add both string with, and it will give something, it will make something out of it. C language, right? It is loosely typed language, right? So that is it. We will be understanding now random number in next video. For this video, that's it, and we will meet next time. Okay, bye.